This video will be about solving systems of equations by elimination, and I'm going to give two examples, and these will be fairly easy, and there'll be a different video that will have a little more difficult problem. So let's get started. The first two equations that we have are really easy to use elimination for because the coefficient of the x terms are opposites. The first one has a negative 4x and the next one's got a positive 4x. And the nice thing about that is when I add these two equations together, which is what we do with elimination, I am going to basically have eliminated the terms of the x's without doing very much work. So negative 2y plus 8y is equal to 6y. All right. Negative 12 minus 24 is equal to negative 36. All right, and all I'm going to have to do is divide both sides by the coefficient of the y. That's a 6. And they cancel out, of course. And I end up with a y equals negative 6. All right. So basically, I've got half of the work done. Because what we're looking for when you're solving a system of equations is a point, if there is one, the point of intersection of the two lines. And I'm looking for one point that works with both equations. So a point, of course, is an x and y coordinate, or basically I have to find both variables. In this case, an x and a y. So I've got half of it done. The way to find the other variable is to plug in this y value into either one of the other two equations. Well, it looks to me like the second equation, this one, is probably going to be a little bit easier because I don't have as many negatives or minus signs as the first equation does. So let me try the second equation, only I'm going to rewrite it, but instead of a y here, I'm going to write negative 6, now that I know what, or at least I think I know, what the value is. And then I can go ahead and solve for y. Now I'll have an equation with only one variable, so I can solve for that. First I'm going to go ahead and simplify this, and that's going to give me 4x minus 48 equals negative 24. And then I'm going to go ahead and add 48 back to both sides to get close to trying to eliminate or to isolate the x term, or the x. I'm going to bring down my 4x, and that's going to equal 24. Because negative 24 and positive 48 equals 24. And that is going to give me, once I divide both sides by 4, x equals 6. Okay, so I think my answer is 6 comma, the 6 comes from down here, so 6 comma negative 6, and the negative 6 comes from the first solution I got. Now what I need to do is make sure that this is the right answer, and the way I do that is by plugging these two values in for the x and y in both equations and see if I get a true statement. So let's start with the first equation. Negative 4x minus 2y. Well, instead of negative 4x, I'll do negative 4 times 6 from right here minus 2. Instead of y, I'm going to use negative 6 from right here equals negative 12. And that, of course, is going to give me negative 24 minus 2 times, or negative 2 times negative 6 is positive 12 equals 12. And of course, negative 24 and 12 together gives me a negative 12. And the only reason this isn't true is because I forgot to put the negative sign right here. All right, I should have just brought this down as is with my negative sign. All right, negative 12 equals negative 12. That is a true statement. So this solution does work on the first equation. Now I've got to make sure that it works on the second equation. All right, so instead of 4x plus 8y, I'm going to write 4 times 6 plus 8 times the y value, negative 6 equals negative 24. All right, that's going to give me 24 minus, okay, 8 times negative 6 is going to give me negative 48 equals negative 24. And that negative 24 equals negative 24 is a true statement. Looks like I've got a great solution because it works for both equations. Okay, now we're going to move on to a problem that's just a little more difficult. The reason it is a little more difficult is because I don't have coefficients that are opposites right off the bat. I'm going to have to do a little manipulating on one of the equations to make that happen. Now, I've got a couple choices here. For me to turn the x terms into opposites, I could multiply the second equation by 4. That would give me a 4x and a negative 4x. That'd work. I could also multiply the second equation by 3. I don't know. I think I'll go with the second option. I'm going to go ahead and multiply the entire equation, the entire second equation, by 3. And how you write it kind of is up to you. I like to put parentheses around the entire equation and then show what I'm doing. I'm multiplying by 3. I'm going to change the entire second equation by multiplying everything by 3. 3y, 9y, the negative 6 becomes negative 18. Here's where I like to always rewrite the other equation right below it so they're kind of like right by each other. So I'm rewriting the first equation. It's not changed at all. Okay, I'm drawing a big line so that I can add the two equations together and see what I get. 3x minus 4x equals negative 1x, or I should just write negative x, right? Negative 9y plus 9y. Well, that was the whole point of doing that, was that it ended up with opposites that would cancel each other out. So, yay, it worked. All right. Now I can add together negative 18 and positive 9. And I get negative 9. All right. So negative x equals negative 9. And I'm going to just, I guess, think of this as dividing both sides by negative 1 to cancel out those negative signs. And x equals 9. At least I think it does. Now I've got, of course, I'll have to test it. Since I know the x value, I am going to plug that value into one of the two equations from the beginning. And I think I'll pick the first one. Or no, I think I'll pick the second one, actually. The one that says x minus 3y equals negative 6. Only instead of the x, I'm going to write 9 right from here. Okay? The rest of it was minus 3y equals negative 6. And now I'm going to solve for y. All right, so I think what I'll do is take away 9 from both sides. And I'm going to get negative 3y equals, well, negative 6 and negative 9 added together gives me negative 15. All right, I'm going to rewrite this up here at the very top. Kind of just start my next column. All right, negative 3y equals negative 15. Well, best thing to do right here is to go ahead and divide both sides by the coefficient of the y, the variable I'm trying to isolate, and that's going to cancel out, of course. And I'm going to end up with a y equals negative 15 divided by negative 3. The two negatives cancel out, so y equals 5. At least I think it does. All right, so I believe that the answer is 9, right? 9 comma 5. Well, now what I need to do is make sure that that is true. So I'm going to take my two original equations and plug in my values, 9 and 5, and make sure that I end up with true statements for both equations. And that's the only way I know for sure that it really does work. All right, so let me start with the first one. Negative 4, instead of x, I'm going to write 9 plus 9 times, instead of y, I'm going to write 5 equals 9. Well, let's see if it does. Negative 4 times 9 is 36. And 9 times 5 is 45. All right, equals 9. If I add these two together, I get 9. Yay. Well, it looks like this set of values for x and y does work and give me a true statement for the first equation. So I'll put a little check mark there. Now let me do the other equation, the second one. X minus 3y equals negative 6 from right up here. All right, only I'm going to replace the x and y with these values here. which is what I think my answer is. All right, I'll just put a little question mark here, because I'm not 100% sure yet. Okay. X. Instead of X, I'm going to write 9. Minus 3y. Well, instead of y, I'm going to write 5. Equals negative 6. Okay, so 9 minus 3 times 5 is 15. Equals negative 6. Yep, that gives me 9 minus 15 is negative 6. Equals negative 6. And that's true. So that does work. So I do have the correct answer. I'll go ahead and erase my question mark now that I know for sure. Thank you for watching this video. If you'd like to watch me solve a more difficult problem, please watch the next video. Thank you.